How is everybody? Are you ready to fall asleep after eating lunch? Because I am one of the world's leading security experts. That is utterly untrue. I am going to talk to you today about cross-site request forgery, but since our theme is 80s, it has to be Funkery. You can follow me on Twitter at DJSmith42. I want to tell you a little bit about me. This is me and my beautiful family. On the left-hand side, I have 5 children. That's how much I value security. I have quintuple redundancy for my posterity. In my spare time, I like to ride my bike. The picture on the right-hand side is my father and I after completing a 340-kilometer bike race with matching socks. More blah blah about me, blah blah blah. I am a panelist on the JavaScript Jabber podcast. I am co-host of the Soft Skills Engineering podcast, which we launched earlier this year. Any listeners? Yeah. 1, 2, great! I am the engineering director at a company called HireVue based in Salt Lake City, Utah in the USA. And I am a professional nice person. I take it that seriously. As you know, I am a leading expert in security. I actually have a very real degree from university name here with a doctorate in CSRF. And so that's what qualifies me to talk to you today. And it definitely was not generated from fakediploma.co.uk. Just want you to know that. Also, here's a little disclaimer. If you find a problem in my talk, show me the attack vector. I have had many discussions with people over the years about cross-site request forgery, and confusion abounds. If you have an issue with something I say, I would love to hear about it, but please show me an example of it. It's so much easier to talk concretely with these things than it is to talk abstractly with hands waving. I'd rather see the code. So show me the attack vector. Disclaimer number 2. This is going to be a very fast whirlwind introduction to CSRF, but today, we will have office hours at 2:40 p.m. You are welcome to come and talk to me. I would love to look at your system, and maybe we can decide whether you have a CSRF problem, or maybe you have a CSRF solution you'd like to talk about it. Come on over to the office hours room. I'd love to talk to you. And tomorrow, we'll also be having a panel on security and performance in the morning at 11:45. Okay. My real qualifications to talk about this subject are that I designed HireVue's, our web platform's company's CSRF prevention over the last 5 years. We have passed 4 annual security audits with full source code disclosure, on-site penetration testing, and multiple penetration tests from various vendors over the years. I have successfully argued about CSRF with a trained security professional. So, why should you care about CSRF? The answer is that this is a very subtle and easy to mistake security problem that has plagued many companies, including ING Bank, that their customers became victims of fraudulent money transfers a few years ago, and YouTube fell victim to CSRF, where attackers could actually do almost any action on behalf of other users because of a CSRF vulnerability. Here's how CSRF works. Here's our agenda. We're going to first talk about how it works, then we're going to talk about how baddies exploit it, and then we're going to talk about how to stop the baddies. Okay, 3 parts. But first we need to talk about web authentication. Before you can understand CSRF, you must understand how users are authenticated on the web. The first thing you need to know is that HTTP is stateless. How many have heard this phrase before? HTTP is stateless. I didn't know what this meant for a lot of years, but what it actually means is that we use cookies, basically, to authenticate. And the reason we have to use cookies is because every single web request must be re-authenticated. Even if you're using the same connection over and over to talk to the same web server, it must re-authenticate you for every single request. And so I want to walk you through one of these examples so you can see how this authentication tends to work. So follow the mouse cursor here. Step 1. The web browser issues a GET request to www.example.com and does not send any cookies along. The web server then says, you don't have a session cookie in this request, so what does it serve? The login page. Then the user, or the browser, shows that login page to the user enters their password, and then when they hit submit, the browser posts a login request to the /login endpoint, and then the web server takes that request, sends it off to some user store backend, maybe a different service, maybe just a database lookup, And when it is found to be correct, their username and password match a known user, then it will generate a random session identifier, which will then go back to, ultimately, the browser in the form of a session cookie. In this case, it's going to be called session ID. Different backends will name these cookies differently, but session ID is a pretty common one. And you can see here 12345 is the same session ID that the backend gave. The browser then stores that cookie on the user's computer in persistent storage. And the next time the user tries to go get www.example.com, this time a cookie will be accompanying that request that says my session ID equals 12345. The web server doesn't know that this is actually the same person who made the last request, so it has to check with the session backend and say, who is session 12345? The session backend says, that's Bob. Then it serves up the home page customized for Bob. Okay? A couple of things to note on this diagram. The first one is that the session ID is set as a cookie in a response header from the web server. And once the browser gets that response header cookie, it will then store it for future use. And in the next request, the browser actually sends that same value back to the server. Okay? This is just Web Fundamentals Authentication 101. All right. So, cookie privacy. Browsers actually are responsible for preventing websites from accessing each other's cookies. The last thing we would want is for you to be able to log into a bank and then have one cookie and then go log into Facebook and give that same cookie to Facebook. Now Facebook can go log in as you at your bank. We wouldn't want that. So cookies are scoped by host, among other things, which prevents browsers, or browsers then prevent users from seeing cookies across hosts. Actually, I said users. What I meant was they prevent servers from seeing cookies that belong to other hosts. Okay? They enforce this. It's their job. What this means is that if I have a baddiesite.com that wants to do bad things to me, it cannot read my cookies from mycompany.com. Okay? It just can't. Browsers will not send that cookie to mycompany.com. But, and this is where cross-site request forgery comes in. Okay? Everything I've said up till this point is just introduction and background. But even though servers can't see cookies from each other, browsers love to send cookies to the website that issued them. They love to do cross-site request forgery, which means that if, for example, I am a bad, evil doer, and I create a website called www.baddiesite.com, and I put this simple HTML, which I'll walk you through here in a minute, I can actually cause, if I can trick a user into going to this page, I can cause the user to go to their own website with their session, if they have one, and do bad things to their account. So let's walk through this. All I've done is I've declared a simple form with a post, and the action is https://myapp.com, delete my whole account. Okay, just like that. That's something that you guys have all implemented, I'm sure. And then a script tag down here, as soon as the page loads, it finds that form. It's the only form on the page, so it's index 0, and it calls submit. So what does the browser do when I feed this HTML to you? You'll see a blank page for a brief moment, and the next thing you know, the browser does a post over to myapp.com, and even though baddiesite.com is currently serving the page, the browser will happily send all my cookies for myapp.com over, including the session cookie. So now myapp.com thinks that I have just requested to delete my whole account. Okay? Does that make sense? So there is a little bit of trickery involved here. A bad guy has to actually first trick a user into going to baddiesite.com, but once they do, CSRF takes over and the browser happily submits this request to that website. All right, so that is CSRF, and I want to show you what that looks like visually. So imagine here's Chrome, and by the way, this affects all browsers. Browsers do this because this is what the web specification says to do. This is not like a vulnerability. This is by design. Imagine you're Chrome, and you have your internet cloud. You have myapp.com and baddiesite.com. Chrome will go, and assuming previously that you were logged into myapp.com, that is a precondition, and that you currently have a valid session with myapp.com, which is actually a very common thing to do, especially myapp.com. Great website. You guys go there a lot? No? Okay, maybe I'm the only one. So you get this evil HTML, and then it responds with it, and then your browser immediately does that post back to that form, and the next thing you know, it's passing along that cookie with my session ID, and boom, my account just got deleted. Just like that, bye-bye. Okay, that's how it works. That is how CSRF happens. Now I want to show you that in action. So I've prepared a small Express.js web server that is vulnerable to CSRF. I have not put in any CSRF protection. I'm going to show you the code, and then we're going to fix it to make it not CSRF vulnerable, and we'll do the exploit, and I'll show you it actually working. So I have here a fake bank website. It's the world's least secure bank. It also cannot store any money, which is great, but it has this endpoint called /money/transfer. And if you are logged in, then it will do a pretend transfer to whatever account you specify in the post body, and in the amount of whatever amount is specified in the post body. And that's what it'll do. So you can see it's not actually doing a real transfer, but just for the purposes of demonstration, you can see that this is how it would happen. Okay? That's how that happens. I've also got a very basic page here that has a login form and some other stuff. So let's go look at this running. So here's my very real bank. I am not currently logged in, so let's go ahead and log in. And I'll just type in my username, which is Dave, and my super secure password. And now I'm going to log in. Now you can see I'm at the same website, but this time my session told it that I'm logged in as Dave. Okay, so now I have a cookie. And if we were to go look in our application tab of the Chrome Inspector, you can see I actually have a session ID right here. See, the value is this randomly generated string. That's my session ID. On the back end, in the web server side, it uses that session ID to look up my name, and it finds that my name is Dave. Okay? All right. Now, I'm going to show you another website that I have built. Oops. Called Bad Guy's Website. And it's just a simple index.html with an iframe in it that points to iframe.html. Now, iframes are not necessary to do CSRF, but it makes it easier to see what's happening if I put an iframe in there. So I'm going to show you the contents of the iframe now. And this should look pretty familiar. This is very similar to the example that I showed a minute ago. It's a post form that goes to myveryrealbank.com/money/transfer. It has two hidden inputs, an account and an amount. And the account is a value that I specified. Let's pretend that this is my bank account because I want to steal your money. And here's an amount of money that looks to be very large, which in the case of my bank account would fail because of insufficient funds. But in the case of this rich person who we are attacking, it will work just fine. And then in here, I'm doing document.forms.submit inside of a short timeout so that we can see it happening. So this website, I have actually deployed to Firebase. And I'm just going to do a refresh here. And you'll watch the website come up. And, oh, must be logged in. Maybe I'm not logged in. Oh, right, because I restarted my server, sorry. Let me log in again. Go over to Baddie website and refresh. Success. Okay, so what just happened here is that I am on this website called csrfexample.firebaseapp.com, and inside is an iframe that did a simple form post, but not to the same site. It went to a cross site. It went back to myveryrealbank.com and executed a money transfer. The same money transfer that I could execute here, on the bank website, I can also execute from any iframe on the internet. Okay, so that is how a CSRF exploit works. So to fix this, we need to figure out a way to identify the sending browser. And the way that we do that, one way to do that is to use a middleware called CSURF, C-S-U-R-F, which is an Express middleware. And it uses cookies, so I'm just going to uncomment those. And then down here, I'm going to install that middleware. And now what's going to happen is that the middleware on this endpoint will require that any post request be accompanied by a cookie whose name is underscore CSRF, and a matching form value or header whose name is also underscore CSRF and has the same value. And I'll talk about that in a little bit more in a few minutes. But now if I go over to this website and I refresh, it just says forbidden. Because that CSRF middleware identified that this website can't possibly be from the same place as the website that I'm actually meaning to host. It must be from a third party, and therefore we forbid it. Okay, so that's the demo. Let's talk about what just happened there. So I think I already explained kind of the process there. We're going to go into details about the cookies and the headers and all that stuff in a minute, but I want to just very quickly dispel several myths about CSRF. You might think that you're already protected from CSRF by virtue of some other factor in your app, but you might be wrong. For example, a session cookie marked with the secure flag will protect you from CSRF. This is not true. In fact, it doesn't matter whether it's secure or not. HTTPS protects me. This is also not true. You may have seen in my example, both of those websites were HTTPS. It does not help. You might think having an HTTP-only session cookie, which prevents it from being accessed by JavaScript, might help. Not true. There was no JavaScript involved in the request at all. The only JavaScript on the whole page was the form submit call, but other than that, it was just a regular HTTP request. You may think that JSON APIs are not vulnerable. Well, these are all form posts, right? Well, that is also not true, and I'll show you a very clever example of someone exploiting a JSON API using nothing but hidden form inputs. And you might also think that I only do things with REST, and therefore all of the things that can alter data for my users must be like a delete, for example. That also won't protect you, because while it's true that HTML forms can't do deletes, they can do posts, which can have harmful side effects. So 5 myths busted. I'm going to go into that JSON thing just really quickly here. It turns out you actually can generate valid JSON payloads from an HTML form using form encoding with some very clever placement of single quotes and double quotes. You can see here I have a hidden input whose name is the beginning of some JSON and whose value is the end of the JSON, including this curly brace, and this results in a valid JSON object being posted to the server. Isn't that clever? Notice the equal sign that slipped in here. Still valid JSON. So some researchers figured this out back in 2012, and it means that your JSON APIs are not safe. So thanks, researchers. Also, in the future, JSON forms might become a thing where you can actually have an encoding of JSON instead of form encoding. So how do we stop them? The answer is we can only accept requests from pages we trust. And how do we establish trust? The answer to that is you must work with your backend people to come up with a scheme. You must have love between front end and back end. You cannot do this alone. Neither back end nor front end can do this without each other. If you read the Angular 2 documentation on XSRF, you can see that they have thought this through, and it will work out of the box provided your back end uses the right names for its cookies and the right techniques, which you can read about here. Let me break down the responsibilities between server-side and client-side. On the server, the first thing you must know is that the server must reject any request that has a mismatched CSRF cookie and header, or that doesn't have the header at all. It must send a randomly generated CSRF cookie to the client, and it cannot be HTTP only for Angular. You also need to use CORS to prevent cross-origin AJAX, which usually by default is in place. And on the client, you need to read the CSRF cookie value for each request, and then anytime you want to make an AJAX request, you send a matching header whose value matches that same cookie value. Angular 1.2 and above do this for you, and the cookie they use, or the header they use, is called XSRF token, and the cookie is called XSRF token. Here's the code for that, which you can read. This is from Angular 1.2. You can see that every single time a request is sent, it goes in and looks and sees if it's the same origin and grabs that cookie value out and includes it in the headers. In Angular 2, it does the same thing using this thing called a strategy, which goes into every request as well. And I won't bore you with all the details there. Here's what one of those requests ends up looking like. So here's an AJAX request to the /foo endpoint. I've highlighted in yellow the important parts. So XSRF token is a header whose value is a randomly generated string. And the is not a header. That is a cookie value called XSRF token. The request also includes a header with the same randomly generated value, and those two must match. So the server can trust this. However, if the server gets a request that looks like this, it knows that it cannot be trusted. It may have come from a non-trusted third-party domain because it is missing the header. And remember, HTML forms, they cannot submit headers, and that's why this works. So from the attacker's perspective, they can control the form post payload. They can write whatever they want in the HTML. They can even control the content type of the form within limits. There's a couple different values they can choose from. They can also control the method for the get or post request. But they cannot control headers. They can't set them, they can't read them, and they cannot control cookies. Because they're running on a different domain, they do not have access to the cookies. All they can do is rely on the browser to forward the cookies. The good news is there is hope for a brighter future. Right now we have to do all these gyrations and dance around cookies and headers, but there is a new spec that is in draft right now to do something called same-site cookies. This is a browser feature similar to HSTS, where, similar in spirit anyway, where you can give a browser a cookie and tell it, do not ever forward this cookie from a cross-site request. Only send it to me if it's coming from this same domain that issued it. And once that's in place, this whole mess will go away. This whole mess has been around for like a decade. So it's called same-site, and it will really help a lot once browsers adopt it. In the meantime, we're going to have to continue jumping through cookies and headers and all kinds of stuff. So in conclusion, you got to stop the hackers. You waited, not me. I'm just waiting for the giggles. Who saw the banana? Anyone see the banana? There you go. So I want to remind you I'll be available for office hours. One of my favorite things in the world to do is to talk to other developers about their CSRF. I don't know why this is fun for me, but it just is. So come talk to me in office hours. I'd love to talk to you about your stack, your back end, your front end. We can look through and see if you have a CSRF problem, and I would love to talk to you through that. So thanks very much for your time.